Well, what we're looking at here is a Philips/Fluke PM6673 universal frequency counter. This is a 120 megahertz counter. I don't know, it was made back in the 80s approximately. And it was a combination of Fluke and Philips. This particular unit was one of the first major efforts to use the microprocessor in the frequency counting area to some spectacular results, to my mind. I found that this unit is extremely accurate and can be, with its large readout, 9 digits, easy to read, bright LEDs, it really pinpoints it, and the oscillator, the master oscillator in this thing is incredibly accurate. So what we're going to do right now is give you well, just first of all, just kind of give you a quick look at it. It's not a flashy unit. They've chosen a what you call it, a natural brown, a muted brown color. Philips is big on this. Very solidly built, solid cabinet, very nice strong handle with locks on it. Adjust your height. All of that works and looks great. Take a look at the rear end here. We have an interface, IEC 625 interface with address adjustments. We can go internal or external oscillator. And then there is 3 positions here for external reset, arming, and frequency average. Right now I've got it set for average. So let's go ahead and turn it on. The first thing you're going to notice is that we've got 9 digits of zeros that pop up. We can do a little check here. I've got it set for a 10-second timer and a roll at the moment. First count we won't count. We'll go for the second. There we go. So we got 10 million all the way down to the lowest level. All right, let's go ahead and turn the gate time up a little shorter, so we've got less resolution, but it's a little faster update. So, and we'll go ahead and turn the check off. We can hit the reset button, go back to all zeros. We got a display hold. We can count. We'd be counting pulses, which we don't have right at the moment. We can go frequency. There's period measurement, and there's a ratio measurement. Gate time is adjusted from here, and we have some filter selections to filter out some interference from high frequency and low frequency and so on. And then the sensitivity control. So let's go ahead and hook up right now. I'm hooking up a 10 megahertz source. It comes from a rubidium unit that's up here. That rubidium unit provides me an extremely accurate signal to somewhere in the 0.01 hertz region, but we're going to just see where we set. I have not, I promise you, adjusted this unit in months. So what it has because it held it. So let's go ahead and take a look what we can get. We'll go up to 10 seconds here on the gate time. And let's just see how we do it measuring the incoming frequency. Alright, there's our first count, 9,999,999.8. So we are 0.2 hertz off of our rubidium standard using an internal oscillator in here that, like I say, hasn't been adjusted in months. This unit was on my bench for the past approximately 2 years, and I'm quite proud of it, quite happy with it. It's been an excellent unit, and I would not be selling this unit, except that I now own its slightly bigger brother, PM6673 instead of the 73. Same basic unit all the way around, except that this one goes to 1.5 gigahertz and this one goes to 120 megahertz. Well, it actually is going to beat 120, I guarantee that, but we'll measure that in a moment too. And as we see, our frequency is still 0.2 hertz different than the rubidium. So marvelous. Okay, let's go ahead and give it a couple of checks and see how we're doing. Alright, we've connected ourselves up to this PTS 500. It's also being run externally off of the rubidium as a frequency standard for its division. So we are reading a 300 kilohertz signal divided off of the rubidium. We're feeding it into this PM6673. I'm going to set you up on a little mini tripod here. Right now we're reading 300 kilohertz to the 0.01 hertz level, and we're going to start turning it up. Here's 400. As soon as this particular reading is over, we're going to turn up the turn down the gate time so we get a little faster response. There's 400 kilohertz. Let's go ahead and make this a 1 second gate time. Alright, let's go 500, 6, 7, 8, 9, 10, 'Let's that's a megahertz there. Let's go 10 megahertz. And let's go 100 megahertz. There's 100 megahertz. 110. 120 is supposed to be the limit. There's 120. 130. 140. 150. 160. 170. Okay. Going back to 160. 61. Right, I'm calling it 160. So we can read accurately up to 160 megahertz on this 120 megahertz unit, as we can see. Go back down to 10 again. Let's see what we can do on the low end. I'm going to switch this around here, so hang on. Okay, at this time, in order to monitor the lower frequencies, I've switched to an HP 3320B synthesizer. We're starting out at the 300 kilohertz mark. And that's the low end that we left off at on the PTS, so we'll pick up from there and go down. I've got you on the tripod here. So right now we see that we are 300 kilohertz, and with a little fraction at the end, about 0.3 hertz, and it's dropping a little bit. That says the oscillator warms up. We're not going to worry much about the frequency and below the 1 hertz mark. We'll make an adjustment if necessary. But right now we're at 300 kilohertz, and we're going to go to 200. All right, 200 kilohertz. There's 100. All right, 90. 80. 70. 60. 50. 40. 30. 30,000 hertz. It's 20. 10. 9 kilohertz. 8, 7, 6, 5, 4, 3, 2, 1. Alright, let's go 900 hertz, 800, 700, 600. Let's go to 300. Cut that short. 100. Here's 90. 80. 70. 60. 50. 40. 30. 20. 10. 9 hertz. 8. 'Let's cut this down to 5. 4. 2. 1 hertz. Okay. Here's 0.9 hertz. Oh, there it is. 0.9 hertz. 0.8. There's 0.8 hertz. Let's try 0.5. Give it a moment. We are right in the 0.5 range. Give it another count. Well, that's it. Looks like 0.56. So I don't know. Somewhere around a half a hertz we've gotten down to. Pretty spectacular. Like I said, the beauty of this unit is in its resolution, the control you have over the resolution, the 9 digits, and the fact that it is an extremely stable oscillator internally. Beautiful unit. Been very happy with it. So, along with it, I'll give you a manual, and I'll give you a set of general purpose clip leads. Oh, look at that. We got 0.5 hertz right in the nose. I'm thinking my generator locked in finally. Beautiful. So, happy bidding, and I'll see you again.